Hey guys. Um, for um, for today, we're gonna do a little bit of review so that we don't forget all those key concepts that we learned throughout the year. Okay, and you're going to complete a Google form that would have been a cumulative review, one of those weekly reviews that we used to get every week. So I just want to go over a few concepts that are going to be that you're going to need in order to complete a few of the questions that I think might give you a little bit of trouble considering how much time we've been out of school for. And here are the four concepts I want to go through today. Number one is system of equations. Number two, inequalities. Number three is finding the equation of a line when you're only given 2 points. And then number four are your basic exponent properties, just a few of them, not all of them, but what will help you get through the CR or the Google form. Okay, so let's jump right into it. Let's look at system of equations. What we need to know, a quick example that we can go through. Okay, so for system of equations, guys, remember there are two ways that we always did it in class. You can use either elimination or substitution. And I think if you are in Mrs. Zach Mary's class, you guys use something called the hug method. So if that works for you, that is awesome. I did not teach my students that. So for my students, we're going to stick with elimination or substitution. For Ms. Zach Mary's students, if you guys want to use the hug method, awesome. And remember, the whole point of system of equations is that this is when we're given two variables, right? And we need to eliminate one of the variables in order to find the other one. Okay, so this is when we're given two variables, usually in the form of a word question like this. So let's read this. Brenda's school is selling tickets to a spring musical. On the first day of ticket sales, the school sold 3 senior citizen tickets and 9 child tickets for a total of $75. So right there, I see two different variables. Okay, I see two different variables that I always tell my kids you gotta use a let statement, right? I need to know what these letters are representing. I'm not just gonna go all willy-nilly and put random letters that don't represent anything. So right off the bat, I want to use my let statement. What am I trying to give a variable for? What word in this sentence should I want to use my let statements for? Well, here it says 3 senior citizen tickets and then 9 child tickets. Right, so that should be a big giveaway because the last thing I also told my students is the last sentence in this word problem usually tells you what your let statement should be. What is the price each of one senior citizen ticket and one child ticket? Right there, that should be my let statement. Okay, so I'm going to let S equal my senior citizen, the price of one senior citizen ticket, and I will let C equal the price of one child ticket. Okay, and then we got to set up our system. So on the first day, they sold 3 senior citizen tickets. Okay, so I'm going to represent that by 3S. And they also sold 9 child tickets. So I'm going to add that to my 3S. So plus 9C for a total of $75. So this will equal 75. That's my first equation. I should have another one though. The school took in $67 on the second day by selling 8 senior citizen tickets. Okay, so I'm going to keep that with the S, so 8S, and 5 child tickets, so plus 5C. And again, they took in $67. So this is going to be equal to 67. So here I have my system of equations. And now I got to solve for S and for C. So the way we typically did it in class, guys, was elimination, hug method, if you guys want to use that. Okay, I have to eliminate either S or C by getting the same number but with opposite values. So just by looking at this, I know I can't multiply the top just by any number and it's going to eliminate with the bottom number, right? Because these, not really a low GCF here, right? So what I'm going to do is I'm going to eliminate C, okay? What I'm going to do is multiply by 5 on top, everything by 5. But then on the bottom, I'm going to multiply everything by, what do you guys think? If I'm trying to eliminate C, I'm going to multiply everything by -9. Okay, I'm trying to eliminate C in this case. Okay, every piece. Don't forget that other piece over there. So what this is going to look like is something like this. I'm going to have 15S, this is the top equation, plus 45C equals, and then you guys got to pull out the calculator for this, see what we get. 375. Okay, that's the top piece. On the bottom, -9 times 8s will give me -72s. -9 times 5c will give me -45c. Ooh, look at that. That's nice. And then -9 times 67 will give me -603. Not very nice numbers, but the one I care about came out nice because now I can eliminate C just by adding these two together now. Right? Remember how this goes? So I'm going to add these new equations together. -72 or 15 plus a -72. You can just put that in the calculator, right? And you'll get a -57s. Positive 45c plus a -45c. Those cancel out. That's exactly what we want. And then 375 plus a -603 will give me a value of -228. And hopefully, when I solve for C, this works out nice. Right? I have to divide both sides by -57. So that cancels out. And I do that math there. So -228 divided by -57. And it does work out nice. I get C is equal to 4. And what's nice is I already have a let statement. C is the price of one child ticket, so that means that one child ticket is $4. And then when you get that, you can take this value and substitute it back in to your original equation, right? I can take this, let's use purple. I can take this value and substitute it back in for the C's over here and then solve for S. Okay? I'm not going to finish it, but that's how you would do that. Nice, clean example. Not very clean, actually, but it's okay. Here we have inequalities, okay? Inequalities are the symbols that look like equal signs, but they're not quite the same, right? You have these symbols, less than, greater than, or you have less than or equal to, or greater than or equal to. less or equal, greater or equal. Don't forget about those, okay? And then say you have maybe a nice word example like this, and it wants us to write the inequality. So what do we got? Abby is ordering Italian takeout for a big game night with 20 guests in attendance. A family-sized lasagna will feed at least 6 guests, while an extra large lasagna will feed at least 11. It wants us to write the inequality that describes this situation, and it gives us our let statements, which is cool. That means that we don't have to make our own let statements, right? X is the number of family-sized lasagnas, and we know that there should be 6 of those, while Y is the number of extra large size lasagnas. Well, that should be able to feed at least 11. Okay? So, setting this up, again, we need to feed at least 20 people. That's what this is saying. We want to feed at least 20 people, which is what it says right here. So to set this up, we know we're going to have family-sized lasagnas, and we also know we're going to have a number of extra large lasagnas, and we can take what it told us up here. Family-sized lasagna will feed at least 6 guests. So that means that I should attach the 6 to my X. Extra large should feed at least 11. I'll attach the 11 to my Y. Then it's a matter of what sign goes here in this circle. Because it's going to be less than 20, greater than 20, less than or equal to 20, greater than or equal to 20. If we want to feed at least 20 guests, right? We want to feed at least 20 guests. Well, that tells me I'm going to want this to be greater than or equal to 20. I don't want it so that I don't have enough to feed the guests. If it said that it was less than or equal to 20, that means that it would feed up to 20 or less. That's what this would say. But this one is saying this will feed at least 20 or more. Okay, so you just got to be careful with how you represent your inequalities. Okay, let's go through another example. Finding the equation of a line given only 2 points on that line. So, we have this example. What is the equation of a line given the points 1, 6 and 3, 2? Well, this is a good example because we can remember what the equation of a line should look like. Remember slope, intercept, form is y equals mx plus b, where m is your slope and b is your y-intercept. Right? And this is the form that we typically use in order to get the equation of a line. But the only issue is it doesn't give us the slope, and it doesn't give us the y-intercept. We're missing both of those. It only gives us 1, 6 and 3, 2. So there's a few things we need to figure out. We got to figure out what is the slope and what is the y-intercept. Thankfully, we know the formula for finding the slope, right? It's m equals y2 minus y1 divided by x2 minus x1. And would you look at that, we have all 4 of those values. Here's our x1, here's our y1, here's our x2, and our y2. So we're just going to do a little plug and chug here. y2, which is 2 minus y1, which is 6, divided by x2, which is 3, minus x1, which is 1. This becomes negative 4. Bottom becomes 2. So the slope comes out to negative 2. Okay? So we're one step closer to finding the slope. Slope is good. Now we got to find the y-intercept. So remember how we do this. Now it should look like y equals negative 2x plus b. But notice how we can use either one of these points. We can use 1, 6 or 3, 2. Right? Because we have x and y. So our x, we just have to substitute in one of these points. We're not going to use 1 and 2 or 3 and 6. We got to use something that's consistent, either this one or this one. And we just have to substitute in and we can find and solve for b. So solving for this, let's use this first one here, right? Let's use this one, 1, 6. So my y is going to be 6. So 6 equals negative 2 times x, which is 1, plus b. And then I just have to solve for b. To get this, I got to add 2 to both sides. So I get 8 is equal to b. And there we go. For a final answer of, to put it back in y equals mx plus b form, my m is 2, or negative 2. So negative 2x plus 8 is the equation of my line. Okay? And last but not least, some basic exponent properties. Make sure you guys write this down. If I didn't say that at the beginning, write everything down. Okay? Because these are all important. And these are things that tend to stump us a lot. If we have some number, x to the a times x to the b, it equals that same number raised to the a plus b. So if I had 2 to the third times 2 to the fourth, it equals 2 to the 3 plus 4, which equals 2 to the seventh. It does not mean 2 to the third times 2 to the fourth. This doesn't mean 4 to the seventh, right? I'm not multiplying my numbers. They have to be the same numbers. This does not work. You got to keep the same base. Same for this. If I had 2 raised to the fifth divided by 2 raised to the first, that's telling me the rule is 2 raised to the 5 minus 1, which becomes 2 to the fourth, right? And then last but not least, if I had, say, 2 to the second power all raised to the third, right? The way we did this in class is we expand this out. Always expand it out so you never get it wrong. So that what this is saying is that I'm going to write this out 3 times. I'm going to do 2 squared times 2 squared times 2 squared. And then I can simplify each of those. 4 times 4 times 4, which is 16 times 4, which is 64. Which is also what you would have got if you did it this way. The property says, right? This would be 2 to the 6th power, which is also equal to 64. But we do it this way. This is the way we should be doing it, okay? And those are the 4 concepts I want to go over, guys. Make sure you do the Google form associated with this